All right, everyone. So I'm going to kick this off with a quote from Questlove. He says, "I'm not here to perform. We're here to have a party." All right. So likewise, I'm not here to teach you about ML. I'm here to learn with you. We're all interested in this stuff, and so we're going to explore this together. All right. So let's get started. Polymarket. Polymarket is a betting website, and for technical legal reasons, this is called a prediction market. And prediction market has a very specific regulation that applies to it in the US, where it shows up under CFTC and never, ever under SEC, even if you're betting on stocks. So even if you're betting on crypto, thing out there called conditional token framework, and there's a very specific reason that it works this way, and everything else is going to copy the way Polymarket works. The vulnerabilities of this approach are well known because it's actually been done before. Something called Augur did the same exact thing before, but they were too early, and they didn't have the right marketing approach or specific people pushing it. There's a marketplace out there, and you can make bets. There's yeses and nos. You bet on yeses and nos. Do you understand how the yeses and no works? Okay, so normally, if you've ever done a sports bet, you bet on Team A or Team B winning. So there's a very slight difference that I kind of want to bootstrap you with. Here, you never bet on A or B wins. You always bet, does this happen, yes or no? Does A win, yes or no? Or does B win, yes or no? And those are complementary because A and B cannot both win the same baseball match. So, you know, one of them's going to win. But there's a reason that they do it that way, and if that's too technical, we don't have to get into it. But it really lines up with tokens and blockchains. So it's a really nice setup. Today, we're going to talk about machine learning. So this is actual teaching a machine to predict something and get a great outcome based on a loss function that is objective that you define. We're going to talk about backtesting because you have to do backtesting. You cannot YOLO if you're making a robot. Only humans YOLO. Robots don't live, so therefore they cannot YOLO. And execution. This is trading operations, trade ops. So we'll get into this. The goal here is I want you to understand how does Polymarket work a little bit, as much as you want to go into it, we'll go into it. And then, is it possible for you to create software that trades against this stuff? And you can write your own software and, if you want to retire based on this, that's your problem. But you can execute the same strategies I'm executing and I don't care. I've made enough people rich. I don't need to keep these things for myself. You can get rich off this too if you want. Now, there's a cool thing that makes it exciting right now. If you've ever been interested, there's an XKCD for this. If you're ever going to learn a new skill, make it like your life depends on it. If you need to learn a regex, imagine you're coming in with a rogue and you have to save the day, and if you can't find the address in a huge data set, then you're not. You know this XKCD? Thank you. All right, we're going to have more XKCD references today. So if you can't learn like your life depends on it, you're not going to learn the thing. So your life could depend on, making a lot of money, if that matters to you. And today, from now until the end of this year, Polymarket as a data set, as a system, is just small enough that it can fit on your laptop. But soon it will not. So today you can do a full 100% backtest against the entire history of Polymarket. But next year, after the pumping that it's going to happen in this market and maybe Europe, you're not going to be able to do that anymore. So it's like you're in it, you're early. So you can do this backtesting. And in the future, you'll have to use sampling and other approaches. But now is a very exciting time where you can get in, you can do it. You don't need one of those Mac minis that are maxed out with, quarter terabyte. This is he's not here. Quarter terabyte of RAM. You can do it on a normal laptop. And I have an M4 with 20 cores, and it works. It works in a reasonable amount of time, and it's really exciting. All right. Polymarket. How does it work? How does it start from an idea? So you're a person, this is an intention, and then how does this end up on the blockchain? So there's some flow here. With blockchain, there's a lot of distinction between what happens and then what happens on the blockchain. And it's very important to know when does the decision made, when does the thing clear, and when is it permanent. This exact decision was actually the subject of a lawsuit of one of our friends here. And as traders and as machine learnists here, we need to know exactly when the data is available. So you have an intention. What are you betting on?
Sports.
Pick one.
World Cup game.
World Cup. So we've got the A round, the B round, and then you've got a blockchain wallet. So the blockchain wallet is software on your computer, and under the Polymarket system, there's actually two ways you can clear the transaction. The one way is you can sign a thing yourself, nobody does that, or you can use the hosted wallet, everybody does that. So you would sign something using your computer, you would provide a signature, it's actually called a message, if you're familiar with Ethereum. So this is a message, not a transaction signature. Use a message, and you send the message to the internet, and it's somewhere, I think, physically around UK, where there's a hub, where there's a router that takes these messages, and they pay the gas. So if you don't know what gas is, doesn't matter. So there's a bundler. So your message goes into a bundler where it is played onto a blockchain. This happens, Polygon network is a block every 2 seconds. So every 2 seconds, it spits out and it goes, it executes. It's permanent, the trade is permanent, is locked, is irrevocable. And that goes onto the ledger. This signed transaction is on the blockchain, and we will be querying the blockchain for historical data. This is the actual data of the closed transactions of the tokens that are taken from Mike, given to someone else, and money that went the other direction. Everything's there. It's the perfect thing. Now, there are other data sets which we will not be using. There are data sets produced by the bundler, by Polymarket. What I don't like about this is you have to trust that Polymarket is not hiding data, that the historical data is accurate, and that it is apples to apples with the way that they produce data today. It's very important to me that we have a reproducible data set, and so I'm only relying on the blockchain data.
Is their data set not open source?
Their data set is public, but you have to query it, and only they can give it to you. And it is not published, so you have to get it row by row. And I'm guessing they're going to give you the correct rows if you query it, but that's not good enough to me.
Yeah, sure.
I want to have a fully transparent, reproducible data set, because that's the approach. Everything we're doing here, you should be able to use these techniques on Wall Street. So if you go down north on Broad Street to NASDAQ for their exchange, you can use these techniques, a lot more data, bigger machines, fatter pipes. But this is the correct approach. We're always going to use reproducible, actual data that we care about. And so I didn't want to skimp out and use their Gamma, it's called their Gamma API, which spits out data that doesn't meet those requirements. Because my goal is not to take over Polymarket. My goal is to learn the skills that will allow me to trade options on Wall Street properly. So, not that that's my goal, but that's what I want to learn. Learn like your life depends on it. All right. So, this is where we're going to get the data. It floods in. And right now, today, for the low price of $30 a month from, or if you get a free key to access some of these API providers, you can download all of it, and it's only a terabyte, or you can get it for free off of that disk right there. And yeah, so you just scrape this data. We're going to scrape data. The way this works is on blockchain, I think probably everyone in this room understands that blockchain is a bunch of blocks, and there's data in the blocks, and they're permanent. Okay, that's all you need to know. Now, all of the world that participates in the blockchain has the same data, so you can ask any one of them, give me this data, give me that data, and it's all fungible. They all have the same exact data, and you can query from any provider and get the exact data that you want. So if we get this data, the full data set is 1 terabyte. This includes different parts, and this is the raw data. So obviously there's a lot more, there's like 30 tables, but basically what's going on is there's something called a market, and so a market will be the World Cup game, a specific game and a specific match, which has an outcome. There's a testable outcome. Did they win? Did they lose? And then there's cop-out answers like what if the game's canceled? They have solutions for that too. Every possible outcome for a specific thing. And then there'll be a yes-no token. They split the tokens for yeses and nos. You actually trade the yeses or you trade the nos. That's the mechanics of this thing. And we have people. So that's going to be an individual account trader. It doesn't have to be a person. It could be a robot. But somebody who has some account that has tokens that are at risk. Money at risk. And then we're going to have fills. So we're going to fill these orders. Now, the way this works is, this is called a central limit order book, CLOB, C-L-O-B. This is a technique which is popular for a lot of crypto books. It's also popular for a lot of real marketplaces, but there's different ways to close orders. If you've ever done TradingView, has anybody looked at a level 2 order book for equities? Have you ever seen the reds and the greens? So there's the reds and the greens, and there's a price that you're clearing today. Has anybody seen this? You can trade stocks, right? That's what's going on here. But you don't actually see all that. We don't see that data. We only see the clearing price. These are the clears. So when actual matches happen, there's going to be a maker and a taker, some price, and then whatever token it was and when it happened. There's a lot more detail. But the way it works is you either have a limit order, so you sit on the books, or you have a taker order, where you take liquidity off of the books. So Apple's at 400, and you're like, okay, if you buy it at 400, you're not doing them a favor because you're taking an order off of the book. You're hurting them. But if you say, I want a better price at 375, you're helping. Does that make sense? Why is that? Now it's a quiz.
If they still have it in their like portfolio or like their ground, then they'd still be able to have.
They can offer that to somebody else.
Yeah.
Okay? So why are you the sucker for buying at 375 instead of 400?
You're tying up your money. Right.
You are at risk, so it's not your choice. If you buy at 400, you are deciding when to close.
Yeah.
But if you put it at 375, you have a commitment that's outstanding, so you're at risk or selling it to you at 375 when it's worth 375. So when you're at risk, when you take on a risk, that's valuable to someone else. So now we're starting to think a little bit more like traders and market participants because that's relevant here. Oh, sorry, one last mechanical thing is a taker can clean multiple makers. So the makers, they're just lined up. They're lined up. Here's a buy at 300. Here's a buy at 301. Here's a buy at 302. And the stock's now at 305. The sale comes, and then it sucks this guy out, and then it sucks that guy out, and sucks that guy out, and it closes at 300. So the one taker's driving in and picks them up. It's obviously going to pick up the best one first. It's going to close the 302 first because that's the best price. Wants to sell for more money. So it's going to sell at that price, sell at that price, sell at that price. End result: one shark eats 3 fish. So the shark is the taker, and the fish are the makers. So when you see it close, you just see, oh, there's a trade at 300, 302. There's a trade at 301. There's a trade at 300. But it matters what direction it's moving and who caused it to move. Now, let's just think about that. This is logical. We're not like programming. We're just talking logic here. Why does it matter who made the offer at 300 and then the 301, the 302 versus who took the offers and then bids? And then versus when the certain things happen. Like what are the different scenarios? Why does the time matter to you? Okay. So the final one is the current price. It's the close price. Even though this is atomic matching, even though we all cleared at the same time, this order closed last. So that is the last price. Even though it's atomic, you would look at the average and be like, oh, it's an average close price of 301. No, it's a final close price of 300 on an atomic match. What else we got?
So why time matters?
Yeah, why do you care who the makers and takers are? Why do you care what direction the thing is moving?
Because my commitment as one who's selling at a certain price might be tied to a timeline. Like maybe I'm shorting at this date. Right?
Yeah. So when did the action happen? And these things, we don't know when they made that commitment. This is a lower bid, this is a higher bid, right? So this person was in line behind this person. This person had a more risky thing because it's going to get picked up. This one is far away from the closing price. So you can look at how far away were they from the actual closing price. So these are the things that will turn into features when we do feature engineering for machine learning. So the way that I'm explaining to you in English, that is how you're going to explain it to your LLM who's going to write code for you. You don't need to know it much more than I'm explaining to you. This is basically how you're going to talk to your senior programmer who's going to write your robot for you. But you need to understand these concepts, and that's why we're talking like this over beers rather than writing code and doing a code review right now. We can do a code review, no problem. Now we're going to look at a specific way that we're going to put things on disk, because this is a little bit different than you might be used to in your web application days and your MySQL/Oracle DB days. We're going to be using DuckDB. And DuckDB does the same queries that you're used to, basically. And we're going to use flat files called Parquet files, which are just compressed CSV files. And there's some magic in there that is really cool. And we're going to use them in a certain way. So let's just talk about Parquet and DuckDB for a second. So normally, even when I started this project, I was like, okay, I got a terabyte of data. I have to query it a whole lot. What should I do? First thought was what? SQL.
database.
I use a SQLite. I put a SQLite SQLite file on my disk, it was a terabyte large, and I was querying it. And the performance was what it was. And the problem is that SQLite is designed for a very specific use case, and SQL and Oracle. They're designed for joins and lookups of a single row at a time. User logged in. What is their name? User did this thing. Put it in the database. User wants to buy this. What is the price? They need to do that very fast. They're designed for that. Look up a thing. But the things that we're doing are a different class of problem. What we're doing is more like, look at every trade this person has ever done, summarize it, and what were the prices? Were the prices far away from the market or close to the market? Across the entire history of the past 2 years. Every query is like that. Look at all of these trades, transform them. So for transformations, what you want to do is you want to take all the data, transform it, and spit out another data set. This is exactly what DuckDB does. DuckDB is a database, Parquet is a file format. So you don't even need a server to run this. You could use a server, it doesn't matter. But it is quite sufficient to keep these compressed CSV files on your disk and then have DuckDB rip through them to spit out your query results. Now you might do some temporary tables, and we'll talk about that in a second, but you're going to have a big data set, terabyte, that's going to rip through it, pull exactly the sections that you want, and we have partitions instead of selections. But none of that matters. All you need to know is that these are the technologies you're going to need to know. And by need to know, I mean these are the buzzwords you need to know for your architectural decision when you set up trading robots. If you don't use these, it's going to be at least 100 times slower. For one example, I was following an account. So I was executing an account strategy where I wanted to identify good accounts and I wanted to copy their trades. So in this scenario, this strategy, I was able to run across a terabyte database file, the whole data set in 7 seconds. You can't even read the disk that fast. I was like, how is this happening? And then I started to learn how Parquet works and why this ridiculous use case actually works. It can load this many files and execute a query this fast for a terabyte data set on an M4 server with 24 gigs of RAM and 20 cores. And it uses your cores. It will smash your cores. And I was like, this doesn't make sense. So you're going to be using these type of techniques against your data. And again, now is the golden time of working with this data set before it blows up. After the World Cup, it'll probably still be small enough, but someday this is going to be a 10 terabyte data set, and we won't be doing this for fun. I'll only be having this meeting at the NASDAQ building for people that have Mac Minis that are half a terabyte of RAM, in their backpack. So, purple is the raw data. So this is the data that we got from blockchain, and it will be useful to have a few temporary data sets. So this is the technique we will use. I have some of these temporary data sets, but I want to inspire you to think about how you might be using them. Now we're getting a little bit into the machine learning part and the feature engineering. So the basic idea for machine learning is you're going to have a bunch of data, you're going to have an objective, and you're going to have a model that minimizes the loss function. So you want to see, okay, so let me put this in English. You want to, let's say your thesis is certain accounts make money, and those are the ones we want to care about. We want to forget everybody else. So your thesis is some accounts make money. Your loss function is accounts that make the most money. And your approach is going to be suck in data, find accounts that make money, and spit out that list. That's an approach. So we're going to show you how to do that. There's plenty of other theses you can use. Just give me some other trading ideas. Spreads. Okay, give me a spread example. Short term?
Or bands.
Bands. Bands that make money. Yep.
Yeah, you just create a buy band at the bottom and a sell band at the top. And then you just take advantage of the oscillation that happens in sort of cash flow.
I call this ping pong. So you have a range. So you can do, okay, so this is a short-term market maker approach where you buy and sell the same thing. I want to be a little more general because there are a few different ways you can do that. One of them is have a band. If it goes above here, you sell. If it goes below here, you buy. And you just ride that over and over. You're able to hit back and forth as many times as you can. You can also use a ping pong approach where whatever it is, you just make a market on both sides. So whatever the price is, you're buying and selling, and you're moving. So that's not a band. It is adaptive. You can also have a band with a skew. You think it's going to go up, but you want to make it money along the way. or down. And so these are short-term approaches. So what are some of the features you would need to track that? So what data do you think you might need?
Moving averages.
Moving average of various sizes.
Sure. Yeah.
So we're now using technical chartist terms.
Yeah. Technical indicators might help. RSIs, Cat6,
Yep.
crossovers. Yeah.
Yep. So we can use technicals, and we can follow them with each tech. So you have to implement a technicals calculator. All right. Give me another approach that we could use to trade. Another thesis, a broad thesis that we can apply in the whole market.
Arbitrage between the markets,
Between
like Kalshi and
Polymarkets. Okay, so you can take something that's here, something that's there, and then you can buy the same or comparable or synthetic things that are close enough. So you can do them direct, like a specific match in the World Cup. You can also do them like on Polymarket. You can bet on who's going to be the Democratic nominee. Oprah Winfrey's on there. There's like 90 of them. So you can, but those same 90 people that might not be on caution, right? So you can say that, well, if Oprah Winfrey wins the Democratic nomination, then Newsom won't. So those are related, but not exactly the same. But they're close enough that you can shove it into a computer and run with it. Okay, so direct or synthetic or related outcomes we can look at. Give me more ideas. Okay, so for this one, what would you need to track? Like what type of data might you need?
Well, would you need to somehow get the Kalshi data too?
Yep, so you need to get the same exact thing from Kalshi, right? You really care about the exposure definition and the resolution source. Because one of them, if it's a tie, they might give you 50-50. The other one might do something else. I guess it's usually 50-50. But yeah, so what if the match ends like without a resolution, and you're long here and you're short there, and you think they cancel out, but they don't. So this was actually a serious problem for other crypto firms where they thought a wrapped dollar on USDT here versus DAI over there is the same thing, and they were not. So they got squeezed on that. Watch out for that. More straight trading strategies. This is the fun part.
Buy and hold.
Buy and hold. Get in, stay in. Yep. So how do you execute buy and hold?
Buy and then hold.
Well, what type of data do you need to make that decision?
You need a market that you want to buy and hold on. I guess.
How do you identify the things you want?
Yes. Taste. Your
Okay.
Personal taste.
But we want to think about this as a large scale.
Momentum, like buy and hold into momentum or something
Okay.
like that.
So there's different ways. You can use technical, so you can have a momentum play. You can have buy and hold based on external information, like I think this is going to happen, but I don't know when to buy. You can set a market price. You can set a follow price, like whenever it dips. I don't care what the price is, but once it dips, get in, stay in, and just hold it to resolution.
Right.
You might want to know how far away you are from resolution. You might not want to execute buy and hold for something that doesn't resolve for 2 years.
Right.
We were just talking about that.
Yeah, monthly markets.
Monthly markets, right?
Markets are great.
So you know when it resolves, so you want to have them as features. So the things that you make part of your decision-making process are called features. If it was Excel, they would be columns. There would be columns for every row of your data set, and then you make a decision and you execute. And again, we want this thing to work while you're sleeping. If it's machine learning, it should work while you're sleeping. So you have to be dispassionate about how the thing works. So you want to have all your features in and just let it execute as it's supposed to. Okay, so based on the things that we've talked about, technical plays, timing plays, we've got ping pongs, we've got cross markets, scalping. Okay, so you want to look for a very specific dip or something like that? Yeah, so this is technical.
Okay, would it be similar to your ping pong approach though?
Yeah,
Or just
absolutely.
like ride the wave to buy and sell, buy and sell?
Yeah. So we've got short term. I gave you another one, which is follow lookalike accounts. So you can follow an account. You can say this guy has got a history. You can also have a thesis that some people are inside information, and you can look for outsized 3 or 6 sigma events. You can look for 10 sigma events. You can look for something that is so out of there, and somebody you hear it on the news all the time. I'm just going to quote something, and we'll get political for a second. Sorry. So you'll hear in the news, somebody that Trump knows bet $50,000 at the Department of Defense, and they won. We think it's somebody at the Department of Defense, and then we went to the war the next day, and they won. We've heard that a few times, but nobody's ever told, and that's fine. And I have no opinion or knowledge about this. But what I do know is that I've never heard on the news say, and here is every other $50,000 bet that has ever been made that's not been expected. I've only heard the one where it was unexpected, it was large, and then we went to war the next day. Like, that's the only one that gets on the news. So listening to the news on TV, you're going to lose money if you make decisions based on that. You have to do backtesting across the entire market in order to be able to detect anomalies. So this would be called anomaly detection. So you would look at market behavior that is anomalous. And I just had to say insider trading because that's been in the news. That has been an anomalous event detection in the news directly related to the Polymarket for current events that have happened in the past month. Like, we are riding the wave on that. So that could be your thesis. Any bet that's over X dollars. But that might not be sufficient because the market might be very liquid. So it has to be over a certain dollar amount. An X sigma event, so X sigma, like far away from the normal curve. Something that's very unexpected, which you can quantify using features. Okay, so I'll give you some of the features that I've thought up. These are very basic. So what you want to do is you want to have a data pipeline. So we've got this purple stuff. I've got code out there. It will generate this purple data. Every 5 hours, you got a new Parquet file. All the trades are in there, all the tokens, everything's in there. But now we want to suck this into a format that's going to be useful, that we can feature engineer. So here's one of them, account personality. So this can just be per account across the entire data set of every token, of everything you can bet on. How much money did they move? How much money did they make? What exposure? How long are they? How short are they? And here's another one. Out of 24 hours a day, how frequently among those 24 hours are they trading? Are they trading each of the 24 hours every day? Or are they trading only some hours of the day? So that would really help you detect what? Bots. So this is an account personality. So this would differentiate human versus bot behavior for somebody who really needs to get mental health. So, but these are things that you can quantify. So don't be like, it was a robot. Be like, no, the robot scored Shannon entropy across time is greater than 5. Like, that's what we want to hear. So we want to hear quantifiable features in your data set that you can make money off of, or trade, or execute your thesis. You don't have to make money. Token the market. Okay, so back a second ago, we were talking about these yes tokens and no tokens, but these are two marketable securities, and they actually relate to a market. And then it even goes a little layer deeper, which I'm not showing here, which is where, like the winner of the World Cup, you got a lot of teams. Each one of those teams has a yes and a no. So you can bet for Venezuela, no. You can bet for Bolivia, yes, even if they're playing. So every one of these, you can buy the yes or the no, but they're all related. So this might be useful to you if you want to stay out of the World Cup. If you think that market is fixed, you want to be in it, or you think it's fixed and you want to be out of it, whatever the thing is, you want to identify behaviors. And so looking at the markets or the superstructures could be important. Again, you don't even need to know what that means, but you need to imagine that there might be some relationships between different markets. And that is something that you want to collect every partition, every 5 hours, and just let that chill in the data file because you might get alpha out of it. So it might help, might not. And then you can get into market highs and lows. So we were talking about this. We were talking about based on band prices. So you want to know, how big is the band? If the band is like this and you're betting here, you're sitting pretty, because it's probably going to blow past your band and you're going to make a toll across the bridge each way. So if you've got a band, what I'm saying a band is this would be a price chart from time going on, price going up. And if you're seeing it go like this, there's a lot of volatility that you can cash in on. Because every time it passes your band, buying here, sell, buy, sell, buy, sell, buy, sell, buy, sell, buy, sell, buy, sell. Now, the other way, if your band is like this, and the action is like this, then it's very likely you're going to take on an exposure you didn't want. So it's going to come down here, and it's going to stay down there, and you're never going to sell. So that's something you just need to basically understand logically like that. You don't need to know the code. You don't need to know the numbers. What you need to know, this is a concept that you're going to want to have in your future. So you got to think about your hypotheses, and then you sort of get your data around that. And then we're just going to shove the data in, and it's going to do the math for us. Okay. So this is data science. This is the basic approach. We want to do this every time. If your approach is let's buy some things, you will lose, and you won't learn anything. So you're not going to put that in your resume like I lost some money. Okay, so that's not like fun. It's not helpful, and you're in the wrong place if that's what you want to do. Is that how you buy sports bets? No, you follow. This guy has a podcast. He interviews managers. He looks at different sports teams, and he's the Mr. Moneyball right here. So he's serious. And so he would be the buy and hold approach. So he would study something and know that he wants to get into a bet. Just what I know from him. So basically what we want to do is we want to have a hypothesis. We want to get a machine that can execute this hypothesis. I recommend 24 gigs of RAM. You want to do backtesting. So backtesting means you're going to take this hypothesis and using the best, as much data as you are allowed to execute against, you want to test it as thoroughly as possible. Now, in this room, with this data set and everything we're talking about, the good news is you can execute any darn hypothesis against this data set. It's only a terabyte. I ran statistics in 7 seconds against it. Your hypothesis might take longer to test, but any hypothesis we can think of, we could probably test it 100% against every trade that's ever been made in this market, which is great. When you go to NASDAQ, you have to also make this, you have to make a trade-off. You have to decide, okay, we're going to test it on 1% of the data between these 3 days. It's like, bam. Like, that's not a lot to go off of. But they go through petabytes and exabytes of data. So we don't have that type of hard disk space. And then usually you're going to run into a moment, like why does my outcome suck? Or if I'm trying to follow accounts and there's 100,000 accounts and only 3 of them are worth following, that's probably a sucky model.
So are you doing all of the within this data? Or, for example, to the sports betting, looking at, okay, when are the injury reports coming out for a particular game, and having that information and feeding in, like, this account always seems to, 10 minutes before an injury report comes out or a roster comes out.
For me, a big thing is like roster announcing. Like for the World Cup right now, I've made sure to like track rosters from previous games and then see, is this the same, like, similar roster? Because some friendlies, they'll just like, use a whole different team than the actual team they're using. So that should be an irrelevant game. You know what I mean? Any staff in that game, if they use like Team C, whatever. So like certain things like that. But like you said, that only happens like an hour before the game. So it's important to kind of update the data.
Yeah, so it's like how you use that
Yeah.
external. Because I feel like that, to me, would be gold to be able to pair those two things together. You would find something.
Yeah.
You have to, if you can't timestamp it, get out. So if you have the injury report but you don't know when, you're leaking time. That is a time leak. You have to stop, breathe, and walk away. Because it's like you will make a mistake. You will use the information that was not available at the time. You will see patterns that don't exist. You will think you've found a miracle, and you will be so wrong. And it will not work. You will lose money, and you won't know why. So if you've got this approach and you know when the report came out, timestamp it. Anything that's timestamped can be directly shoved into this with great outcomes. Now, you can also estimate. So if you know that the report always comes out, like if it's an official report, and you know the official report always comes out 12 hours before or something like that, then you can do that. You can say when should it have come out, use the third-party data source, and you shove it and you estimate. Obviously, it would be much better if you knew exactly when it came out, publicly or semi-publicly or something like that, so then you would be able to see the patterns. Yeah, so you've got to backtest, and so as you're doing this, every time you're backtesting, every time you're doing anything, you're making a git commit. You're taking code, you're shoving it in. Every typo you make, every time the thing crashes, you're making another commit, you're saving the commit, and then you're executing. Because everything you need to do needs to be verifiable, reproducible, transparent. Because when the thing runs and it's working great, and then it starts losing money, and you're like, why is it losing money? You don't know. There could be a typo in your code. You don't know. And then you delete the program, and you start again, and then you're like, oh, I wanted that old program. But it was working, but then it stopped working. You can't do forensics without data. You can't do it without reproducible code. So you're going to be stuck in this spot a lot, which is fine. And guess who can help you the most with this? Guess what technology is out there that's really good with coming up with new ideas and telling you why something didn't work and giving you a variation?
Wait. Can I say it?
Yeah. LLMs. It's great for this. Oh, I got knocked down. Get me back up. Bam. New idea. Version 2. And then you get to this habit where you're just hypothesize, test. And for me, this is the most exciting part. I don't even need to make money. As long as I have a hypothesis, you need to always be able to identify these things and go right to the next approach. if you start going to production, that's this part right here. You go to production with something you don't understand, you're going to lose every time. And you won't know why, and you're going to hate yourself. I've been there. All right, so trade-offs. Here's what it actually looks like. This is the last slide. So, until we got some notes. This is how it actually looks like once you've figured out your approach. You're like, okay, I've done my back testing, I've got my thing, now I want to go run it. And this is not financial advice, not trading advice, and I don't know if you can execute this in the United States, and I don't know where you're allowed to run Polymarket today, and I don't know which markets you're allowed to trade. This is all hypothetical. But if you're going to go to production, what you would do, you could have some type of a trigger. So you're going to watch data, and something's going to happen. It could be an external data source. It could be a roster report was dropped. It could be a band. You've identified a band that was programmed before your thing started. It could be an adaptive band. It could be watching market data, and then it finds a trigger. Or it could be a specific watch list. It could be an account. You've got 100 accounts that you want to follow no matter what they do. It could be N sigma events. It could be based on an irregularity. It could be based on specific holdings that you have. An account strategy is just sell everything I have. That is an account strategy. Actually, that is the most important account strategy that you should implement first. Exiting. Just dump everything now so you can get your cash back to proceed. So what you're going to do is you're going to have some type of trigger mechanism. And so you're going to be at the normal state. So this is a state diagram. And there's exits, which I didn't show. But there's your ready state where you're just collecting data. And then the first trigger hits and you do nothing. And the second trigger, and then the nth trigger, and every condition is simultaneously satisfied, and that is when you execute a trade. The trade happens, and then you log it, and you log all of your triggers. This is what I thought I was doing, this is why I did the thing, this is what I did, this is when I did it, here's when it cleared. Now, there's some execution delay. Remember that 2-second clearing thing? Well, there's also network latency. So sometimes if you're following a band, you might be following based on data that's a couple seconds old. So in NASDAQ, you have this problem everywhere. They're working on milliseconds and microseconds. We're working on full seconds. But it will suck if you buy something at a way different price than you thought you were buying. So these things you want to remember. You're like, why did I buy this? If my band was here, why did I buy up there? And you have to go find each one of those triggers because we're going to do forensics on this. So this is what trading operations looks like. Everything I'm telling you is in the code, and it's all public. It's open source, so you don't need to take any notes. So this is what an actual trade looks like. All right. So this is all the different parts of being a data scientist and applying it to financial markets, specifically today to Polymarket, but also tomorrow anywhere else.
On your data there, do you filter out all high frequency stuff to avoid getting into your latency issues and so forth?
Depends on the trigger style.
Okay.
So if you're going to do a high frequency approach, such as bands, well, that's a medium frequency approach. Yeah. But you cannot filter out with that. If you're going to do follows, you have to just get your server closer to the marketplace. You have to put your server in the UK or somewhere. You've got to be closer.
Theoretically, you would do exactly that, which is get a server as close as you could to that data and not try to do it from here.
Yeah, if it was high frequency. If it is based on rosters, that doesn't matter at all.
Right.
2 seconds doesn't matter. But you will get 2 seconds closer if you go to UK or somewhere based on your data source. You might want to be 2 seconds closer to rosters, I think, are infrequent. But if you were betting on something like crypto prices,
right,
a majority of the markets are based on, is Bitcoin going to go up or down in the next 5 minutes? That's the number one trade that clears on Polymarket, that type of trade. And if you want to execute that approach, you need to know the price of Bitcoin from the official Oracle source. You have to, it's not just, what is the price of Bitcoin? Is it what CNBC says? Yahoo Finance? CoinGecko? Like, what is it? Whoever that is, you got to get close to where they're getting data from, and not necessarily in UK. So you want to get closer to the data source. Right. That is what I call high frequency. But everything else doesn't matter. Cool. All right. So if you're going to build this without writing your own linked list, sorting implementation, hash tables, you're probably going to use some type of LLM to write this for you. So I want to give you some of the buzzwords. This is the photo slide. These are the buzzwords you're going to need to track your implementation. If you don't use these approaches, that's fine. You're just going to get there slower. So some of the things that I've learned in writing an application that is too large for Claude code, or Grok or XAI, something that's it's just a little too big for those tools. And so then I had to start thinking like an engineer, which I am, and just think, okay, how should I do this? Obviously, you can delegate a lot of this work to LLM, but there are a few decisions that you need to make as a human, and these are the ones you need to make. One of them is your brain dump. You need to put the whole brain dump in there. Why are we doing this? Don't just say that based on these rosters. Say, I think these rosters have some edge. I think these rosters, people are going to trade on them. Immediately? Later? Why? Are they going to have impacts outside of the immediate scope of the roster? Is it going to affect other people? These are things you want to watch. I think this market is going to have an impact on that market. If you don't say these things, the AI can't help you. The LLM can't help you. So you want to brain dump. And brain dump can be a 5-minute query. This can be 5 minutes of you talking to yourself about nothing before it does anything. So plan to invest 5 minutes. This will be the best 5 minutes you've spent in your project for here and anywhere. Next, you need to make all API decisions as a draft, here and for any other software project that an LLM is doing for you. If it can't do it in one shot, if it's not a go make me a video game that I can post on Instagram that looks really cool, doesn't work, and there's no login feature, and there's no server component in 5 seconds, you can do that. Oh, great. And your mom will be like, oh my God, you made a 3D game. If you're doing anything more complicated than that, you need to have some API specification, and you need to have contracts between some of your code and other parts of your code. This is called solid. This is a very basic technique in writing code. That is where you want to be involved. So a great thing to do when you're building software is, yeah, you can even have it go build something first, but when you want to build it the second time, you say, okay, here's what I want to do. Here's my 5-minute explanation. I want you to write all of the functions and none of the code. Just write all the function you think you might need for this, and then argue with yourself on whether they're appropriate. Stop and then read it. You don't even need to know how to code, but you can be like, wait a minute. I think a really important part of this roster matching is the time of when the rosters came. But you don't even track that. That's something you want to stop early before it becomes a problem, because it'll write just for days. It'll charge you hundreds of dollars of tokens, and it'll run, but it'll run slow, and then you'll let it run for a week, and then it'll execute poorly, and you won't even know that you had a good idea because it forgot the time period, which is the critical part. Okay? Then you implement it, then you test it, and then you want to have testing. You want to do 2 types of tests. You want to do code test, called unit testing. You want to make sure your code is correct. And you want to have data test to make sure the data spits out is accurate, formatted the way you want it. If you don't have the right data format, then downstream you won't be able to use your own damn data. So there's 2 types of tests you need for operations: unit tests and data tests. Pipeline. We want to use DuckDB. If you want to use something fancier, something that's going to be fancier, more similar to DuckDB, and less similar to MariaDB. So this is the direction you absolutely want to go. You want to start, anything that is columnar has to be a columnar database because you're going to be doing full data transforms. This is not going to be a row-based database like MariaDB or SQL. Well, it can run on different databases. I'm sorry, it can run on different data layers. But the thing is 2 and 4, you can actually connect DuckDB to a SQLite database. It's just going to suck all the data out of SQLite as if it were a CSV file. It's going to do Duck stuff, and then it's going to spit out as a Parquet file. Or it's going to put it into some other format, a Duck format file. Parquet is perfectly fine. When you're spitting out stuff, you want something to be immutable. You do not want to have a terabyte disk file, like a 1 terabyte long SQLite file. Why? Because as you transform the data, when you want to know why did my trade execute, you need to know the exact data that existed at that time. So what you do is you create permanent immutable Parquet files, and that would be a partition. So it would be a database, like a big database, but it's split up every single day. Every day is a different database file. The whole thing aggregates. This is very basic technology that's built into DuckDB and other data lakes. But when you do it this way, what you can do is you can just take a manifest and hash every file. Keep the manifest and say, here are the files I had at this exact date, and as long as none of those files change or they're checked into S3 or some object store or disk or whatever, you can double check, okay, the hash I had back then was this, the hash I have now is the same thing, Therefore, the file was the same. So you don't need to have a terabyte file every day. Like you would literally need to clone your disk and just have it sit there to evaluate what you did last week. So you don't want to do that. You want immutable files and then provenance. So as you do some of your derived data, so as you make your own derived data based on the raw data, you want to know exactly which files did this come from. Again, you don't need to implement any of this stuff. You just bark these orders and your LLM is going to do this. But this is the discipline you want to make sure is applied. When I have a problem here, you better tell me exactly which file with which hashes came from here, what were all the dependencies, so I can double check it. You're going to use this here, you're going to use it wherever. This is a good discipline. This is a good discipline. That's how you do provenance. Trading ops. Fish don't backtest. All right, don't be a fish. And when you do have a good approach, when you've got the aha moment, like, okay, I've got bands that make it dance. You got the bands that make money. You've got the rosters that make money. You've got something that works. Then you got them. You got them. So now you got to make the decision: how much do I bet? Of paper money, if you're in the U.S. betting things you're not allowed to bet on. So how much would you bet if you could bet? And there's a very specific answer. This has been tested a lot of different ways, and it's called the Kelly criterion. There's math. You don't have to be a finance major. I'm a finance major. You don't have to take the courses I took. You just need to know this is the word you need to shove into your LLM so you're not like, bet all my money. Because betting all your money will always lose. One bet will not work at some point. If you bet all of your money every time, that you are guaranteed to lose all of your money. And then once you have no money, you can't double nothing. Double times nothing is 0. So there's a very specific answer to that, and that's called the Kelly criterion. And it just saved you 2 years of finance school. So you just type that word into your LLM, and then use that to make your bet sizes. And this is how you trade on Polymarket. So this is everything. So send your resumes here if you're looking for jobs, and send your job posts here, so I will send it to other people. Thank you.